Hi, good evening. I'm Jaganmohan, Assistant Professor in Mlritm, Marri Laxman Reddy Institute of Technology and Management. Today we are discussing about registers and types of registers. Actually, what is register? A register is a small and very fast memory unit. It is a small memory unit. Actually, we are having 0 to 7 bits. It means 8 bits register we have in the CPU. CPU contains large of registers, many of registers. Each register having 0 to 7 bits. So it is nothing but 8 bits. In 8 bits, it contains memory. In registers, we are having flip flops. Flip flops stores data. In register to register communication will be done in the CPU. Register to register communication will be there, and the after communication, the whatever we are giving the input, that will be processed in the CPU through the registers, and we are getting the outputs. Types of register we need to see, and we'll see the full of explanation about types of registers. Actually, it is located inside the CPU, that is called central processing unit. In central processing unit, the register will be located, and it is a temporary stored data and instructions or addresses. It is temporarily storage data means we are giving the input means that will be stored in the register. In register is the temporary storage. It will temporarily store the data, and it is responsible to process the data to one register to another register. The communication will be done in the CPU, and we are getting the output. The instructions will be processed through the registers, and the addresses will be stored in the registers as per temporarily only. And the registers help in the CPU perform operations quickly and efficiently. The registers can do very fast operations in the CPU, like whatever we are giving the input in to the CPU, that will be performed within fraction of seconds to the CPU do the operations through the registers, and we are getting the output. They play an important role in the executing programs. While we are doing some programs like C, C++, Java also, the communication will be done in the registers only. The operations performed in fraction of seconds, we are getting the output also. And there are different types of register listed below. Like we are having various types of registers. Like we need to see the types of registers, like accumulator registers, programming counter. One is that programming counter, and a register general purpose register, and instruction registers, and memory address register. This is called MAR also. MAR is nothing but memory address register, and memory data registers. It is nothing but MDR, and stack pointer and floating point registers. We are having various types of registers, and the instructions cycle will be like fetch and decode and execute. The three steps will be followed by the CPU. Like in the register, we are having these types of steps. Three steps performed in the registers, like fetch. First, we need to fetch. Fetch means nothing but fetch means getting the next instruction from memory. It is next instruction from memory. Suppose one instruction is executed through the registers. After that, the next instruction will be fetch. Fetch is nothing but it will pull the through the memory. The what is the next instruction? It will gather from the memory, and it will do the operations on the CPU, and will get the output. And the computer checks the program counter to know the address. The program counter will be check the address, and the whatever the instruction will be executed, the program counter will be do the address of the registers, where it is located exactly, and it will bring the instruction from the memory into the CPU. In the instructions bring from memory, actually it instruction brings from memory. In memory, we are having a lot of instructions. The instructions will be pull with the memory and into the CPU. This is the first step of the instruction cycle, and it helps the computer know what to the next. If it is nothing but one of the instruction will be executed means, that is first we need to fetch the all instructions. that in memory located a lot of instructions will be located, like large of data will be located in the memory. The data will be the registers, the instruction register will take the instructions and executed properly in the properly through the registers. This is the first step in the registers. Fetch means nothing but it will bring the instruction in the memory and it will execute the first step. After next step is decode. Decode is nothing but decode means understanding the instruction. Whatever we are giving the instruction in decode, it will decode the instruction. Decode is nothing but if it is we are giving the decimal equivalent number means nothing but we are giving the some data to the input as a 20 means it will convert to the decode means it will system understandable language is zeros and ones only. Mission and the this is called mission understandable language also. It will be decode means those of data converted through the zeros and ones. It will be system will be understand and do the process. It will do the operations on the CPU. The CPU interprets the instruction. It will interpret the instructions. It identifies what operation to perform. In decode, the content, large of content, zeros and ones data converted through the converted into binary code. What operations need to perform in the decode? In the decode operation, the operation will be performed. Like what operation need to perform CPU, like addition operation, subtraction operation, like move operation, and it is operation. Which data or registers are involved? The registers involved in the step. This step decides the next action of the computer. It will this step decides the next action of the computer. Next action of the computer, it will decides what is the next operation. And execute is nothing but execute means performing the actual task. Whatever we are giving the task, that will be converted in the binary code in the decode stage, and execute is nothing but it will execute the code actually, and the CPU carries out the instruction. It may perform calculations, transfer data, and compare values, store results. These operations will be performed. Like perform calculations is nothing but it will perform various operations like calculations, addition, subtraction, multiple data, and transfer data. The transfer data is nothing but A to B. The register to register, the data will be transferred one place to another place. This is called transfer data. And comparing values, like compare a to a value to b value comparison will be done in the CPU. And store results, the results will be stored in the one another register. Suppose we are having three registers. Suppose c is equals to a into b. Here c is the one register and a is the one register, b is the one register. Here A into B register will perform addition, multiplication operation, and we get the A into B operation, and the result will be transferred to the C register. This is the final step of instruction. After execution, the CPU moves the next instruction. It will be completed means it will go through the another instruction. If the instruction will be executed means these three steps will be performed. First step is fetch, the code will be fetched, and decode, the code will be decoded, and execute, the code will be executed. And memory hierarchy, the memory hierarchy, computer memory is arranged in levels. These arranged in levels. Each level has different speed, size, and cost. Each level has having different size and the different speed also. And memory closer to the CPU is faster but smaller, and memory further from the CPU is slower but larger. This man arrangement is called memory hierarchy. And the diagrammatically CPU register represented as level 0 we are having CPU registers. In level 1 cache is nothing but junk files will be stored in the cache. And main memory, the instructions will be executed, and secondary memory and territory storage. The memory hierarchy diagram will be located here, represented here. And CPU register located inside in the CPU. CPU registers also located in the CPU inside. and fastest memory in the computer. It will also it will perform the fastest operations in the CPU, very small size, and store data is needed immediately and used to during calculations and instructions execution. These also CPU registers also will be used for calculations and instructions execution. Instruction execution is nothing but whatever we are giving the data, that will be decoded in the decode stage, that will be understand to the machine language, that will be executed. This procedure will be called one of the instruction means fetch, decode and execute performance. Three steps are called one instruction. Cache memory is located between CPU and RAM. Like it will be located in CPU and RAM also, between RAM also. Very fast but slower than register. It is also very fast. We have to compare with the registers. It will be little bit slower. And stores frequently used data. Whatever we are frequently using the data, that will be stored. That will be stored in the data, and reduces the need to access lower main memory again and again. Reduces the need and to access lower main memory and again, makes the system work faster and makes the system work faster. Accumulator register, they are having we are having various types of registers we are discussing now. The accumulator register, it is a type of register. Main register used to for arithmetic and logical operation. It is used to mainly arithmetic operations and logical operations. Arithmetic operations is nothing but we are having arithmetic operations means addition, subtraction, multiplication, division. These are called arithmetic operations. Logical operations meant and, or, not and XOR. These will be located like machine understandable language. This having some symbols and some truth tables also we had seen. And stores data taken from memory, holds intermediate results during calculations. It will give the intermediate results and for calculations. And operations like addition operation, subtraction operation and multiplication operation and division operation are usually performed here. Finally, result may stay in the accumulator or be moved another register in the memory. These calculations will be performed on the accumulator register. It will be stored in the register or either transferred to the another register memory also. And programmer counter register, it is called PC register, stores the address of the next instruction. Whatever the instruction will be executed, after that the next instruction of the address it will be stored. Suppose one of the instructions executed in fetch stage, the another next instruction will be processed, but before that it will take the address of the next instruction address it will stored, and it helps the CPU know which instruction to execute next. The program counter will say the what is the next instruction we need to execute. If it is we are given multiple instructions to the CPU, whatever the we are given serial type instruction, that will be executed first in first out manner. It will analyze the program counter, analyze the instructions. What is the first instruction will be executed? What is the second we need to execute? It will analyze the instructions. After each instruction, the CPU automatically updated. After each instruction, it will automatically updated. It will do automatically updated process and continues this process until the program finishes. When it will till the program will be finishes means it will be done continuously each and every instruction in the sequential manner. And general purpose register, it is one type of register used to store the data, memory addresses. It will store the data and it will store the memory addresses. Helps in temporary storage during program execution. Whatever we are executing the program, that memory will be stored in the register as per temporarily only, not permanently. It is used for arithmetic operations, logic operations, and data manipulation. Arithmetic operations, we know addition, subtraction, multiplication, and division. And logical operation is nothing but it will be and, or, not, and XOR also. And data manipulation is nothing but data will be arranging and rearranging. Like it will be changes will be done in the data. It is very important for overall CPU processing. It is very important for overall CPU performance. And fourth one is instruction register. Instruction will be mentioned in the register only. Hold the current instruction fetched from memory. It will hold the current instruction, whatever the instruction will be executing, that will be processing, that instruction will be hold to the instruction fetched from memory. It is fetched from the memory, what current instruction will be hold, and it will be fetched from the memory. It will keeps the instruction while it is being decoded and executed. While instruction executing time, it will be keeps instruction while it is being decoded and decoded, and helps CPU to understand the operation and the data involved. The operation is nothing but OP code. OP code is nothing but it will contains binary information, zeros and ones. The data involves an operands. Operands is nothing but also it is also zeros and ones code only. And memory address register, it is called MAR. MAR stands for Memory Address Register. It stores the address and location of the data instructions in memory. Whatever the instructions will be executed, the data will be stored in the memory, and address also, the memory and the address will be stored in the memory address register. When CPU wants to read and write data, it first places in the memory address in MAR. When CPU wants to CPU needs to read the data and write the data, means the data will be stored in the memory address register. It first places in the memory address MR. It tells the memory where to access data from. It knows where we need to access the data. The memory address know very well. And the next register is memory data register. It is also one of the type of register. MDR stands for memory data registers. It stores actual data coming from memory going to memory. Memory going to memory, nothing but we are giving the data that will be stores on the memory, and again it will be processed through the memory also. So it will be called memory going to memory. And when data is read from memory, and it is first placed in MDR. When if it is we need to execute data, means that data will be read. The read operation will be performed. When data is read from memory, it is the first placed in MDR. The first place the data will be stored in the first place is MDR, memory data register. When data is written to memory, and when data is written to memory, it is sent through MDR. If it is we are writing command will be using in the memory, it is sent through the MDR. It will be sent through MDR, means memory data register to we are sending the data, writing the data to memory. And stack pointer will be there. Stack point SP stands for stack pointer. It keeps track of the top of the stock, and it will track the what will be instructions will be executed, like serially or non-serial. It will track will be there. And the stack is used to store temporary data and return addresses during function calls. When it is function calls will be done, the return address will be done, and SP increases or decreases when data is pushed or popped. And floating point registers. These registers store floating point numbers like decimal numbers used for scientific and mathematical calculations. Like it is nothing but floating point registers mean the value will be not will be fixed. The data flow, the value will be every time floating will be there. It is also used for mathematical calculations like addition, subtraction, multiplication will be used for floating point numbers. Provide higher precision for decimal values. it will provide higher precision to the decimal values. Decimal values is nothing but whatever we know, like 1 to 10 we are having, it is called in human language it will called decimal numbers. In binary information means it will be decoded through the zeros and ones. Decimals means we understanding human understandable language, used for floating point arithmetic operation. It is floating point register will be used for floating point arithmetic operations. Like floating point means it will be after point it will be after point it will be definitely change will be the value will be not fixed. It will be every time change will be there. uh, the floating point arithmetic operations will be used in the floating point registers. Arithmetic operations we know very well, like addition, subtraction, multiplication in floating point number. An index register is the index register stores a value to modify an address. It will modify the address, and it helps accessing arrays and data structures. It helps in accessing, it will be help for accessing arrays and data structures. It will access through the arrays and data structure. It will improve speed when accessing memory locations. It will improve speed when accessing memory locations. When we are accessing memory location, the speed will be increased. Often used and indexed addressing mode. And it is the completely types of registers and the register what is the operations performed in the registers. Totally registers we are discussed in this video. Thank you very much.